Volume. When you are talking about volume, there are some questions to ask yourself. What in the world is volume? By definition, volume is the amount of space that a shape takes up. This is not to be confused with capacity. This is not how much will fit inside an object. This is how much the whole object takes up. And we do measure volume in cubic units because it is three-dimensional. The three dimensions that are covered in volume are length, width, and height. And because we use the units of measurement for length, width, and height, such as centimeters, yards, and feet, you're going to, because it's three-dimensional, we're going to use the little 3 like we talked about with area. It was two-dimensional, so we used the 2 because it was square units. Now we're talking about cubic units. How many cubes will make up an object? How much space a shape takes up in the little cubes? And so you might have cubic centimeters, cubic yards, cubic feet. You might have cubic meters. All of these are going to be the units that you normally see when you're just measuring length, width, and height, but now we're going to cube it. And this is another illustration like what Mr. Wood did. I lost the original that I had handed out to you guys. It was an email and I can't find the email, so I had to recreate it, and it will probably look a little different than yours, but we'll still use it. As you can see right here, this is a three-dimensional figure. This three-dimensional figure has all of the dimensions we just talked about. It has length, it has width, and it has height. So those are the three dimensions that we are dealing with when we're doing volume. The length of something, the width of it, and then the height. And if you notice, this is just like a whole bunch of squares or rectangles put together, laid on top of each other to create an actual three-dimensional figure. And you can see within the actual illustration, the word volume equals length times width times height. So this is your formula. And because it's three dimensions, this is the first dimension, second dimension, third dimension, we are going to use cubic units, like I said in the last slide. So let's do a little practice with this. I have come across a few problems from the internet. Some of them you will see a three-dimensional figure and the different dimensions will be labeled. Some of them you'll see problems like this where it's just a bunch of cubes put together and you actually have to do some figuring out because it doesn't give you the actual numbers and the units. And you can still use the formula or you can actually count each individual one. So we'll do it both ways. Alright, so we said the formula was length times width times height. So we're going to just plug in our numbers for our formula. So we're trying to figure out the volume of this figure right here. The length would be 5 feet. The width would be 3 feet. And the height would be 4 feet. So when we multiply those together, 5 times 3 is 15. 15 times 4 is 60. So the volume of this figure right here is 60 cubic feet. Remember how we talked with area yesterday? Even though the 3's after the unit, we say the cubic first. Alright, I want you to try to do this one by yourself on the student side. Go ahead and pause me and then check. Okay, so hopefully you paused me and we're going to check our work now. Our length would be 6 yards. Our width would be 4 yards. And our height would be 9 yards. All we have to do is multiply those. So we get 6 times 4 is 24. and then 24 times 9. If you can't do it in your head, you can do a little multiplication problem on the side. 4 times 9 is 36. Regroup that 3. 9 times 2 is 18, plus 3 is 21. So we get a volume of 216 cubic yards. You could have done the box method on this too. You could have done 24 times 9 and gotten your 20 times 9 is 180. 4 times 9 is 36. And when you add those, you get 216. I'm sorry. Either way, you still will get the same answer. You can even use lattice on it. All right, down here, we can use the formula if we want, or we can just count each layer and see how many's in there. I can see from the top layer I have 1 cube, 2 cubes, 3 cubes, 4, 5, 6 cubes, 7, 8, 9 cubes. So per layer there are 9 cubes. There's 9 cubes there. This layer would have 9 cubes, and this layer would have 9 cubes. So when I add all those together, I get the volume of 27 cubic units. So I put units with the little 3 because I don't know what those units are. They may be meters, they may be inches. It does not tell me. I can also use the formula on this one as well. I can say, okay, the length is 1, 2, 3. The width is 3. And the height is 3. 3 times 3 is 9. 9 times 3 is 27. I still get the same answer whether I just count the cubes or I use my formula. So I want you to try both of these on this problem right here. I want you to try using the formula, and I want you to try just counting the cubes to check yourself. Go ahead and pause me, and then we will come back and discuss it. Okay, hopefully you paused me. For the actual formula of length times width times height, my length is 1, 2, 3, 4, 5, 6, 7. My height is my width is 1, 2, 3, 4. And my height is 1, 2, 3. 7 times 4 is 28. 28 times 3, if you don't know how to do it in your head, then you can work it out. So let's do lattice this time for those that are lattice kiddos. I have to make my marker a little smaller. 2 times 3 is 6. 8 times 3 is 24. We got 4, 8, and 0, so it's 84. So I have 84 cubic units because I don't know what the units represent. Now I can check myself by just adding up the cubes themselves. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there's 28 per layer. There's 3 layers. That's where I got that 28 times 3. I can even add it 3 times if I wanted to. 8 3 times is 24. Regroup 2. 2, 4, 6, 8. 84. I still get the 84 cubic units.